Hello students, in this lesson we have quite a challenge in front of us. We are going to find all of this information here for this rational function. So we're going to find vertical asymptotes using limits, horizontal asymptotes using limits, and then we'll of course have to find the domain and the range, and where f prime is increasing, decreasing, where f double primed gives us information about whether the function is concave up or concave down, and then we'll have to find local maxes and local mins and such. All right, let's get started. Okay, so first we're going to find the derivative using the quotient rule. So take the derivative of the top, bottom left alone, derivative of the bottom, top left alone. Then I'm just going to distribute that 8x and that 2x, and then I'm going to collect like terms, and we're left with a first derivative of minus 72x over x squared minus 9 quantity squared. All right, let's use that to find the second derivative. Okay, again here we'll find the second derivative by using the quotient rule again. And then we'll simplify that. So minus minus gives us a plus. 2 times 72 is 144. 2 times 144 is 288. Then I'm going to factor out that x squared minus 9. And when I do that, right, I lose one of these powers and I lose that term. And the only thing left in here is this 288, which is 72 times 4. I'm going to use that later. And then we have the minus 72 times the x squared minus 9. All right, so eventually I'm going to cancel these out here. So again, this is just quotient rule and a little bit of algebra with the distributive property. Now let's take that x squared minus 9 and cancel that out. And then I'm going to factor out the 72. And I'm going to take that minus sign, distribute that into that term. But remember, it has to go to both terms. And then I will add the 4x squared and the minus x squared, so I get a 3x squared. And remember, 9 is 3 times 3, so I'll pull that 3 out and I get a 216. And so then my second derivative simplifies to this expression here. This is actually fortunate because x squared plus 3 is always going to be a positive number, and we'll use that to our advantage when we're analyzing the second derivative. Okay, let's do our sign analysis here. So with the function, first derivative and second derivative, we notice that we have vertical asymptotes where the bottom is 0. And notice that the vertical asymptote persists through all three of these functions: the function, the first derivative, and the second derivative. And so the bottom is 0 when x squared minus 9 is 0. And if I factor that out, I get x minus 3, x plus 3. So I'm going to get a plus or minus 3. So that's why the vertical asymptotes are x equals minus 3 and x equals plus 3. Okay, let's do our analysis on the first derivative. So if I pick any number between minus 3 and 0, like let's say minus 2, then that I put a minus 2 in there and I get a negative. But that negative and negative is going to give me positive. And if I put a minus 2 quantity squared, I'm going to get a 4, but I'm squaring that. 4 minus 9 is negative, but I'm still squaring that, so I'm going to get a positive. So negative negative gives me positive, over positive gives us a positive. So that means we're going to be increasing there. Similarly, if I pick something between 0 and 3, like let's say 2, then I have a 2 times, 2 is a positive number, but times a negative is going to give me a negative on the top. On the bottom, I'll have 2 squared is 4, 4 minus 9 is minus 5, but minus 5 quantity squared is positive. So I have a negative, positive, positive, and so that is going to give me a negative for this region. And so that's a negative there. And so then I have negative there. On the other side of the asymptote, I'm going to have the same behavior. And on this side of the asymptote, I'm going to have the same behavior. 0 was our critical point, so that's the only thing I have to analyze. Now let's take a look at the second derivative. Okay, fortunately, if I pick anything in here, this is going to be positive. So actually, I'm okay to pick something like 0 here. So if I put in 0, I get 0 squared plus 3 gives me a positive number. 0 squared minus 9 gives me a negative number, and a negative number cubed is negative. So positive divided by negative is negative. And then likewise, if I pick something like minus 4 or 4, because of these squares, doesn't matter. Minus 4 quantity squared is positive. Minus 4 quantity squared is 16. 16 minus 9 is positive 7. So I'm going to get a positive number. So even if I use a negative 4 or positive 4, I'm still going to get a positive number down here on the bottom because 16 minus 9 is 7. 7 cubed is positive. So positive divided by positive gives us positive here and positive here. So we're going to be concave up here, and concave down here. All right, so let's summarize that analysis. So we're increasing from minus infinity to minus 3. We have to remove the asymptote, the vertical asymptote. And then we're increasing from minus 3 to 0. And then we're decreasing from 0 to 3, and then decreasing from 3 to positive infinity. Again, we have to take out the vertical asymptote. So if we're increasing, then decreasing, that makes this a local max. And you can also see that here because we are concave down here. And again, for concave up, we were concave up to the left of the asymptote and concave up to the right of the asymptote. This thing will never be 0 because x squared plus 3 is always positive, so we don't have any inflection points there. Okay, now let's take some limits. So if I'm approaching minus 3 from the left, so that's here, then notice I'll use a test point. I'll use x is minus 4. If I plug minus 4 quantity squared, I get a positive number. Minus 4 quantity squared is 16. Minus 9 is positive, so I get a positive. So that means we're going up to positive infinity. So I'll put that there. Now, if I'm approaching minus 3 from the right, I'll use a test point of minus 2. That's still going to be positive on the top, but on the bottom, I'm going to have 4 minus 9, and that's going to be negative. So we're going down to negative infinity. So I'll put that there. Now, if we're approaching 3 from the left, I'll use 2 as my test point because we're approaching 3 from the left. Then I will get a positive number on the top, and then on the bottom I'll have 4 minus 9, which is negative. So notice that was similar to our previous case. And so I will have negative infinity there. I'll put that in there. And if we're approaching 3 from the right, then I'll use a test point of 4. And here, that is positive on the top, and then 4 squared is 16 minus 9 is positive 7, so I get positive or positive, and so we are going up this way towards positive infinity, and so I'll put positive infinity there. Now, if I want to do my analysis as x approaches negative infinity, I'll factor out the x squared from the top, I'll factor out an x squared from the bottom, and then x is approaching a very large negative number, but still a large number, so the x squareds are going to cancel. And the 9 over x squared is going to go to 0. So the only thing that's left is the 4. And as x goes to minus infinity, there's no x in here. So that's still just going to give us 4. 4 is constant. So that means 4 is going to be a horizontal asymptote. The analysis is exactly the same if it's positive infinity. It works out the same way. So that means y equals 4 is a horizontal asymptote. And I'll label that here. Y. This is going to be the line now, y equals 4, which is going to be our horizontal asymptote. And just to remind me, and x equals minus 3 and x equals plus 3 are vertical asymptotes. Okay, let's finish up our analysis. So I'm going to find my intercepts by setting y equals 0. That's going to give me an x-intercept. And then I'll divide both sides by 4. X squared equals 0 means x is equal to 0. So 0, 0 is our x-intercept. And then if I let x equal 0, then f of 0 is 4 times 0, which is 0, divided by 0 squared minus 9, which is minus 9. So 0 divided by minus 9 is 0. And so 0 is our y-intercept. So I have a x and y-intercept both at 0, 0. And so now I'll just finish graphing this thing. So there's my vertical asymptotes and the horizontal asymptotes as I sketch that. The graph does go through 0, 0, and then I'm following the concave down and the concave up rules that I had from the second derivative. That's my local max. I'm following the rules for the limits that we had from the left and from the right. And then we can see our domain is going to be everything in the reals except we're going to pull out minus 3 and 3. And the range, we go from minus infinity up to 0. And we get to include 0 because 0, 0 is included in this. And then we go from 4 to positive infinity, but we do not include the 4 because here it's converging to 4, but it actually doesn't cross the vertical asymptote y equals 4 because x is approaching infinity and never actually reaches that point. Now functions do cross their horizontal asymptotes. That is known to happen, like sine x over x, but in this case, this one does not cross its horizontal asymptote, and that's how you get to domain and range. All right, that's the full analysis of this problem. Good luck.